Alright, so I'm going to be doing a short presentation on my cerebral paper topic for the electrical machines course. And the topic that I chose was the DC and AC machines that are used in aircrafts in the past, present, and possibly in the future. So the topics that I covered in the cerebral paper were that I gave a short introduction on what the DC and AC machines are, talk about the primary types of motors and generators that are used, and how they can be classified, DC and AC, and so on and so forth. Talk about the ATR 42-500 and the electrical system used within it. Similarly, I talk for the Airbus A320, and I talk about the DC and AC motors that are used within these two aircraft. Because there were large similarities between them, I grouped them into one. But since the generators that were used were different, I talk about them separately. And then a question came up when I was doing my research on why 400 Hertz was being used for the motors and generators, and not the conventional 50 or 60. So I try to answer that in my paper. And then I talk a little bit about how DC motors could be used in the future in the aviation industry. So the primary types of motors and generators used can be classified between the type of currents. So you have DC machines and you have AC machines. DC machines are primarily dual functioning. So what can be used as a motor can also be used as a generator. And what basically differentiates between them is the type of winding. So you have the series wound, the shunt wound, and the compound wound, to name a few. And then for the AC generator, you have the synchronous generator that's being used in the aircraft. And then for the AC motors, you have synchronous, induction, and the squirrel cage. So for the ATR 42-500, it has three primary subsystems, and one of them runs on direct current, the other runs on alternating current, and the third one runs on alternating current wild, which is basically alternating current with a variable frequency. Since these are engine-driven generators, the frequency, the range exists from 341 to about 488 Hertz, and that corresponds to 70% speed to 100% speed of the engine. And here is a list of the electrical system that's used, or the avionics used in the ATR 42. So you might notice that everything is in twos or in pairs. That's because there are two engines on the ATR 42, and also in case one system stops working, the other can kind of power the buses off that. And so you're not in the air without an important generator. So you have two dual function starter generators with a 30 volt DC. You have the two wild frequency 3-phase Y-connected synchronous generators with the frequency range, and then you have the inverters which convert the DC to AC, which is the AC of fixed frequency. So you don't have an AC generator in there. And then you have the two batteries, and then you have the one transformer rectifier unit, which basically takes the AC wild and converts it to DC in case of emergencies. So you might notice that the starter generator is written as a dual function. So initially, when the aircraft is starting up its engines, this dual functioning starter generator functions as a motor. What it does is that it draws voltage from one of the batteries, and that it uses that to start the engine. As soon as the engine reaches about 45% speed, the starter generator, which is being used as a motor, cuts off from the circuit and starts actually functioning as a generator, now charging the battery. So here's a picture that I could find, which basically shows the two starter generators and the AC valve generators mounted onto the two engines. Then we move on to the Airbus A320. So the Airbus has two 3-pole, 3-phase, brushless Y-connected synchronous engine-driven generators. In this case, however, the frequency is constant, and the speed is regulated at 12,000 RPM. And then you have the rectifier units and the batteries and the inverter. So the DC and AC motors that are used between them would basically be, for DC motors, you have the shunt wound, which is used for air conditioning and heating fans, the series wound, which is used for nose wheel steering and flap movement, and then similarly for the rest of them as well. I've written the functions and the different parameters that would be needed. You might also notice that some functions are being repeated, like the shunt wound is being used for air conditioning, but then the induction motor, the AC motor, is also being used for the air conditioner blower fan. So it's not that one motor is fixed to one sort of job. It depends on the requirement. It depends on the plane. So different motors can be used for different functions. Also, you might see here the DC servo motors and the AC servo motors. So these are basically used for the indication purposes. So in the cockpit, the pilot and the crew can basically see these indicators, like for oil pressure and fuel temperature. Those are through using the servo motors. So this brings me to the question: why 400 hertz? So you might have noticed even here in the first the two 3-pole 3-phase brushless Y-connected synchronous engine-driven generator has a frequency of 400 hertz, and along with the same with the transformer rectifier unit and the static inverter. So, and similarly for the ATR42 as well. So this brings up the important sort of concept which is vital to the aviation industry, which is the concept of the power to weight ratio. Now, I talk a lot more about this in the survey paper, so for those of you who are interested, basically, I cannot stress enough how important the power to weight ratio is. So by increasing the frequency, you're increasing the power per weight. So for those of you who would like to know more, I talk about this in my paper. And then talking about the DC motors and generators that could be used in the aviation industry in the future. So Siemens, I believe, has come up with a DC motor that is what they call, in their own words, a record-setting motor, which basically has about 2,600 RPM. It produces a constant output of 260 kilowatts and it weighs only 50 kilograms. So you're looking at approximately 5 kilowatts to 1 kg as compared to, let's say, a similar sort of motor of comparable power delivering 1 kilowatt for 1 kg, or an electric vehicle that we see nowadays on the roads for 2 kilowatt to 1 kilogram. So, but I mean, there are a lot of problems that Siemens is facing, will face. Is that number one of them is the fuel consumption. So you know the jet fuel has has some of the highest energy density per weight, and it's not really comparable when using a battery. So that is one of the issues. It is certainly viable in the future, but it remains to be seen. So these are the two resources that I used to write my paper. My primary resources, these are my father's maintenance training notes when he was an aircraft engineer. And these are the major resources that I've used in my survey paper. Alright, thank you very much.